Have you ever stopped to think about how an AI can sift through a million customer reviews and just know which ones are positive and which ones are negative? Well, it's not magic, I can promise you that. It's all about teaching a machine to understand the actual meaning behind our words. So let's pull back the curtain and see how this amazing process really works. Yeah, at the end of the day, it all boils down to this. For a computer, phrases like great service and late delivery are just a jumble of letters. They're totally meaningless. So how in the world does it learn to grasp the huge difference in what they mean? Well, the secret is all about translation. We have to convert our language into the one that machines are fluent in, the language of numbers. So the very first step in teaching computers to understand us is translation. We've got to find a way to take our messy, nuanced words and convert them into the one thing computers are absolute pros at handling, numbers. And that translation process? It has a name. It's called an embedding. An embedding is really just a list of numbers, a vector, if you want to get technical, that represents a piece of text. You can think of it like a unique numerical fingerprint for a word, a sentence, or even an entire document. This image here shows it perfectly. You've got your text, it goes into this special AI called an embedding model, and poof, out the other side comes this neat, tidy string of numbers. That's your embedding. The model does all the heavy lifting, figuring out exactly which numbers are the right ones for the right words. So, what's the deal with all these numbers? Are they just random? Not even close. This is where things get really, really cool. These numbers are basically coordinates on a vast, invisible map of meaning. And on this map, words and sentences that have similar meanings become neighbors. This map is a perfect example. Just look at it. This acne cream cleared my skin is plotted super close to this horrible lotion aggravated my breakouts. Now, why is that? Because they're both talking about skincare, right? Meanwhile, my order was late is near extremely fast shipping because they're both about delivery. On this map, closeness means they're talking about the same kind of thing. And that is the million-dollar question, isn't it? How does the AI get this incredible intuition to know that the word king should be near queen, but way, way over on the other side of the map from cabbage? It's doing something much deeper than just reading a dictionary. It's learning relationships. The answer lies in a really powerful training technique. See, instead of only showing the model examples of what things are, it turns out you get much better results by also showing it what things are not. It's all about learning by comparing. This technique is called contrastive learning, and it's all about comparison. You give the model pairs of things, and you ask it a really simple question. Are these two similar, or are they different? And by making it do this millions and millions of times, it starts to pick up on all the subtle features that truly define meaning. So here's the basic setup. You take document A, you take document B, you feed them both into the model, and its entire job is to spit out just one answer, similar or dissimilar. That's it. It gets a little reward when it gets right, and it adjusts itself when it's wrong, getting smarter with every single pair it sees. This is my absolute favorite analogy for this whole concept. How do you really understand what a horse is? Sure, you could list its features, 4 legs, a tail, a long mane, but a zebra has all those things too. The deepest understanding comes from the contrast. A horse is like a zebra, but without stripes. That one point of difference, no stripes, is what solidifies the idea in your mind. That's exactly what contrastive learning does for an AI. Okay, so the theory makes sense, learn by comparing. But how do you actually build a machine that can do this efficiently? Well, let's take a look under the hood at the architecture. It's often called the Siamese twin model. So one of the most popular ways to do this is with a Siamese network, just like we see here. I want you to think of it like identical twins. You have 2 models that are perfect copies of each other. They have the exact same programming, the same brain. You feed one sentence to the first model and another to the second. And because they share the same knowledge, their comparison is always going to be perfectly consistent and unbiased. This really elegant 2-tower design is known by a few different names. You might hear it called a bi-encoder, a Siamese network, or the most famous one in language AI, SPERT, which stands for Sentence BERT. It's just incredibly fast and effective at creating these maps of meaning. Now, I know this all sounds pretty theoretical, but how do data scientists actually pull this off in the real world? Well, it turns out to be a surprisingly straightforward 3-step recipe. First, you have to generate your data, all those pairs of similar and dissimilar examples. Second, you train your SBERT model on all that data. And third, you test it to see how well it learned. But step one, that's where the real cleverness comes in. I mean, think about it. Where do you get millions of pairs of sentences that are already labeled similar and dissimilar? Having people do it by hand would take forever. So data scientists came up with this brilliant shortcut using something called natural language inference, or NLI datasets. Here's how the trick works. In these NLI datasets, you start with a sentence, a premise, like, he is in the cinema watching Coco. Then you get a second sentence, a hypothesis. If the hypothesis logically follows from the first one, like, he is watching the Disney movie Coco, that's called entailment. We can just treat that as a similar pair for our model. But if it contradicts the first sentence, like, he is watching Frozen at home, we can treat that as a dissimilar pair. It's a genius way to automatically create millions of training examples. So, when you step back and look at the big picture, the goal here isn't to just create a dictionary for a computer. It's so much bigger than that. We're trying to build a whole universe of meaning where every word, every idea has its own proper place. And this really matters because this technology is powering so much of our digital lives. When you search for restaurants with outdoor seating, an embedding model finds results that have a similar meaning, even if they don't use those exact keywords. It's how your favorite streaming service recommends a song you've never heard but you instantly fall in love with. You know, it all started with a pretty simple idea: turning words into numbers. But in the process of building these incredibly intricate maps of our language, we've basically given machines a window into how we think, feel, and communicate. And that leaves us with one final, fascinating question to think about. If AI can map the meaning of our words, what will it understand about us next?